Hi everybody, I'm going to be going over the answer key to the Pre-Calculus A semester exam review. I'm going to be going over all of the Unit 1 questions. So I'm going to be setting a timer over here, which is going to count up to 15 minutes just because the videos upload a little easier if they're under 15 minutes. So ignore the timer in the corner. That's really just for me and not for you. Okay, I'm going to begin with the first handful of questions, and we'll stop it whenever we get close. So the first question is in the no calculator section. And it says, sketch the graph of the piecewise function x squared if x is less than 0, and 1 plus the square root of x if x is greater than or equal to 0. Okay, so we can't use a calculator, so let me think about what these two functions are going to look like. Okay. Oops. Okay, so in this one is going to be my graph of x squared, and in this one I'm going to use the equation of 1 plus the square root of x. Okay, now one thing I'm going to consider is this domain right here. This is telling me I'm only going to use the graph of x squared when the x's are less than 0. So let's think about what those are going to look like. So for example, we'll start with 0, and its x is less than 0. So I'm going to name some ordered pairs that are less than 0. I'm going to list some x values that are less than 0. Okay, now if I plug them in, 0 squared would give me 0. Negative 1 squared would give me 1. Negative 2 squared would give me 4. And negative 3 squared will give me 9, right? Because negative times negative is positive. Now, this is less than 0, not less than or equal to. So when I plot this point, I'm going to use an open circle. Okay? And this should look quadratic, right? An x squared graph should look like a quadratic graph. So this is going to be an open circle. And I'm going to go ahead and plot these points. And the negative 3, 9 one I can't fit, and that's okay with the grid that I picked. So it's just going to look something like this, right? I only want the left-hand side of this quadratic graph. Now, this other function, 1 plus the square root of x, is one I'm going to use for the right-hand side, for it says x is greater than or equal to 0. So I'm going to start with 0, and then I'm going to pick some numbers that are bigger than 0, like 1, 2, 3, 4. And some of these are going to give me some pretty yucky numbers, so I'm probably only going to plot the ones that I think are going to fit nicely, because I'm not allowed to use a calculator, so I'm going to try to work a little smarter, not harder. Okay, I know that a square root graph, just from memory, looks something like this. It kind of starts somewhere and then it sort of curves off to the right. Excuse me. So let's think about this one. We've got square root of, if I plug in 1 plus the square root of 0. Well, the square root of 0 is 0. So 1 plus 0, this would give me the order pair 0, 1. And that's a pretty easy one. That one works just fine. Okay, 1 plus the square root of 1. Well, the square root of 1 is 1. So 1 plus 1 is going to give me 2. So I've got another point. 1 plus the square root of 2. That's going to be kind of yucky, so I think I'm going to skip that one for now, because I can't use a calculator, and I think I'm going to do the same thing for number 3, because that one also, is going to give me some decimal, and it's going to be difficult for me to figure out without a calculator. But this one, I think I'm going to get a number for it, because the square root of 4 is 2, and 1 plus 4, or 1 plus 2 will give me the number 3. So I've got 3 points that I can plot. Now, because this one had an or equal to, this one is going to be a closed circle on that 0. So I'm going to go to the point 0, 1, and this is going to be a closed circle. I'm going to plot 1, 2, and then 2, 3, 4, 3 is going to be my third and final point. And this is going to kind of arch off and grow off to the right. And there is my function. Okay, in number 2 it says I have to choose which function, which multiple choice question is in the graph above. And I see that I've got a linear function going this way, right, when x is greater than or equal to 0. And I can see I've got a quadratic. I can tell by the shape of that. And also you can kind of peek at the answer choices, and that can kind of give you a little hint too, right? This is like an x squared. And since it's facing downwards, I'm definitely looking at like a negative x squared. And this looks like it's on the left-hand side of 0, right? So this is going to be if x is less than or equal to 0. Since both of these points meet at 0, 0, it actually doesn't really matter which one gets an open circle, which one gets a closed circle, as long as it's there, as long as one of them has an or equal to, because then it'll fill up the point. So what I'm looking for is which one of these graphs meets this. So I know it's not A. I know it's not A because it says positive x squared, and I know that that's definitely not right, and that actually eliminates D as well. I know that this is a negative x squared, and then a positive line of x. So it's got to be either B or C. So basically the difference is which way are the arrows going, and it looks like I'm going to be using negative x squared going to the left, right? Remember that trick about if the x is on the left, it'll show you the symbol here will show you which way your arrow should point, and this one's going off to the left, so this one must be B. Okay, discontinuity. We talked about 3 types of discontinuity. One of them is removable. One of them is called jump. And one of them is called infinite discontinuity. These are the 3 kinds of discontinuities. I like this problem because it actually shows you one example of each. So that makes it good for our purposes here. Okay, so at x equals 3, x equals negative 3. If we come to our graph here, 0, 0 is right here. Okay, so if I go to x equals negative 3, that's right here, I can see that this graph actually jumped. I'd be coming along this way from left to right, I'd jump up to here, and then I would continue on. So this is the one that we would call jump discontinuity. When x is 1, so that's right here, you can see there's an asymptote, right? Both of these sides of that 1, it looks like it's approaching up to positive infinity, but because it's an asymptote, it's never actually going to hit 1. This is the one that we call infinite. And then the last one, you probably guessed by now, at x equals 4, there's a hole in the graph, right? And so oops, sorry, wrong one. Removable is a lot of times represented by some sort of a hole in the graph. It looks like you took a hole puncher and just popped that one part out. This one we call it removable. Okay? All right, so in number 4, we're given a function, and we're given actually 2 functions. Well, one function that's a combined function. And it says, what is the value of c that will make this function continuous when x is 5? So the problem is that there's like a variable here. There's a c there, and I don't know what that number is. But I do know that I want this function to be continuous when x is 5. So like if you're thinking about it, if I was looking at the graph of 5, I want to make sure that like when one function starts and then the other function starts, that they are connected at that point, basically. So what I can do is sort of work a little smarter, not harder. I'm going to take a look at this value x equals 5, right? And since this equation, the first equation, is incomplete, let's focus on the second one. If I actually plug in 5 into that ordered pair, or into this equation here, I get 5 squared, and the result would be 25. So this would give me the ordered pair, 5, 25. Now I know that this says greater than, right? So there would be an open circle with this function. But we want it to be continuous, which means we want this one to also have a y value of and an x value of 525. I want them to have the same ordered pair. So we basically have to figure out what letter for c would make that function equal 25 when x is 5. So I've got c, x plus 7. I want to know, when is this going to be equal to 25? Now, the y value is going to be 25, and actually this x I can also replace with a 5. Right? I also want this ordered pair to be 525. So let's remove the 7 from both sides. 5c equals 18. And then we're going to divide both sides by 5, and that doesn't work evenly. And without a calculator, because this is the non-calculator section, it'll probably be easier just to leave it as a fraction. So we get the c value would have to be 18 fifths. Blah. Okay, maybe we'll get 1 or 2 more in before the 15-minute limit. Okay, here's another one, and it says, what value of c that will make g continuous when x is 11? So same problem, really. I mean, we just want to figure out, okay, well, if both of them are 11 something, right, I want them to have that same ordered pair, because that's how they'll end up being continuous. So let's use the equation that's complete, which is the second one. So we're going to say, okay, well, if x is 11, let's figure out what that y value will be. Well, let's go ahead and evaluate this. This would be 55 minus 2 would be 53, right? So we know that this ordered pair would be 1153. And I want the other equation to have the same ordered pair in order for it to be continuous. So let's take this other one, 4x plus c, and we want to figure out what's going to make it 53. Now, we also know that the x should be 11. So this is 44. So when I subtract the 44 over, I get c would be 9. So the value of c would need to be 9. Okay. All right. This one says, let me move it so I can actually see it. Which of the following is true about this function? Okay. And again, I'm not allowed to use a calculator. So I need to think about what I know about this kind of rational function. This is what we call a rational function, where we have a fraction in the problem. This kind of function, when graphed on a coordinate grid, is going to have two sets of asymptotes. Okay? So anytime you have a fraction, the denominator of the fraction can never be 0. Okay? Never, ever, 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 ever. It's okay if the numerator is 0. It's just never can the denominator ever be 0. So just keep that in mind. Right there, that's going to be your easiest asymptote. If we set this equal to 0 and add the 3 over, I get that there's an asymptote when x is 3. Okay? So it's going to be discontinuous at x equals 3. This one will also have a vertical asymptote. We're going to take into consideration whether it's top-heavy, bottom-heavy, or a tie. And, so that was something that we talked about. You might want to ask yourself, top-heavy, bottom-heavy, or a tie. And in this one, it happens to be a tie, which means you're just going to use the coefficients of x. So usually, like, the letters that we give that is like a over c, right? If it's like ax, cx, we use the equation a over c. Since both of these are 1, this equation is just going to end up being 1 over 1, or y equals 1. So it's also going to have a horizontal asymptote of y equals 1. Then it's easier to check in your calculator for points, but you can also kind of check the 0, 0. This one's going to end up kind of creating this arch like this. And now let's take a look at the answers here. The function is continuous for all numbers. Well, that's not true because we have an asymptote of x equals 3, so that's definitely out. The function's discontinuous at x equals 3 only, and that is true. Discontinuous at -4, that is not true. At -4, right, like around here, that's fine, right? We're good at -4. So this one's also not right. So it looks like B is going to be the only place where the x value gives us a discontinuous function. So we're going to choose B. Okay, I'm going to stop the video because I'm almost at 15 minutes, and I'll start a new video picking up with number 7.